Good looks, appeal, style. Today's car must have all these features and more besides. It's also a highly sophisticated piece of precision engineering. Today's tough driving environment demands high standards of design, development and testing. Leyland engineers use advanced technology to design cars to exacting standards of comfort, durability and performance. They use computers right through from basic calculations to complex programs. Without the need to build even a single component, it's possible to predict the behavior of a new vehicle and its occupants under all road conditions. A new car begins to take shape when the engineers and marketing men agree on a package. Their specification includes performance, passenger space and luggage capacity. They hand over to styling. Stylists produce many sketches, and some are chosen as a basis for full-size clay models built by skilled craftsmen. At this stage, the design, style and engineering team must meet all practical problems of manufacturing, engineering and legislation. The computer helps to obtain an exact mathematical representation of the clay model's surface. This machine measures a complete full-size styling model to within 1/100th of a millimeter. It does in hours what used to take weeks before computers. The car body engineer uses mathematical techniques to analyze the surface shape. He must decide how best to split the shape into the individual panels which will eventually be assembled into the finished vehicle. These separate panels are stored on magnetic discs. This information is used repeatedly for the design tasks which follow. Whenever drawings are required, they can be produced automatically to any scale or view. Connected directly to the computer, this automatic drafting machine makes drawings at speeds in excess of 15 meters a minute. From the earlier stages of design, structural schemes for the internal panels and understructure are developed. To assist in this development, a complex structural framework is designed and fed into the computer. The computer can now accurately test the structure without the need to destroy expensive prototype vehicles. While structural engineers develop a body shell of the right strength and weight, Other engineers must find ways to make the car ride comfortably, must find plenty of clearance for the wheels to move up and down as the suspension absorbs road shocks and cornering loads. There must be room for the front wheels on full lock for all movements of the suspension. The engineer's practical knowledge and experience are combined with accurate fast calculations by the computer to cut the time all this takes. It also enables designs to be evaluated in the laboratory at an early stage. The geometric layout of components for a proposed steering and suspension system is fed into the computer. In seconds, the position of the wheel for any steering and suspension condition is calculated and drawn. The steering and suspension components must provide the driver with precise response. The drafting machine can draw the turning circle for any proposed steering system. Oversteer and understeer are conditions which can be evaluated by the computer. Designing for safety, our engineers are just about the only people who intentionally crash cars. Leyland engineers go to extremes to protect the occupants should the worst happen. Mathematical representations of the mass and structural stiffness of a car can be analysed by computers to predict what will happen in an accident. There is less need for costly destruction testing. There's no need to build prototypes to test the effect of changing the engine's position, seatbelt anchorage points, or body component stiffness. The computer will simulate them all and determine the best way of absorbing energy to protect the car's passengers. Too rigid a structure may cause the passenger internal injuries. Too flexible a structure will allow the engine or other components to penetrate the vehicle interior and injure the passengers. Safe design prevents accidents. The driver needs maximum visibility, but there are obstructions to vision. The engineer must minimize the blind spots. Once again, the engineer calls on his computer. He must reduce the blind spots without weakening the car. From the Arctic Circle to the tropics, every driver needs to be able to see clearly whatever the weather. Computers help design windscreen wiping and defrosting systems. In windscreens, difficult heat flow calculations are speeded by computer. Different pivot points and wiper blade shapes are fed into the machine. Engineers can quickly calculate whether the most important areas are adequately wiped. This car has been made from several hundred pressed steel panels. More than 1,000 press tool operations are required to make these panels. To design these press tools requires craftsman's skills plus technical expertise. There's a great amount of routine calculation. The engineer must ensure his work meets design and manufacturing standards. Stock material lists must constantly be consulted. The computer is more consistent. It has a better memory. The designer can leave the routine aspects of the job to the computer. He is left free to concentrate on creative design. Engineering drawings are produced automatically in hours, which conventionally would have taken weeks. The clarity and consistency of the drawings is guaranteed. For some components, machining information is passed direct from the computer to a numerically controlled machine tool without the need for drawings. As well as machining dies for press tools, the same computer information is used to design and manufacture jigs, clamps, and inspection fixtures for the assembly floor. You have seen just a few of the advanced computer techniques being used to help Leyland engineers turn a design concept into a quality car.